Welcome back, everyone. We are up to Unit 2, Lesson 13. This particular lesson is another lesson on dividing polynomials. If you look at the lesson notes are almost exactly the same as the ones from Lesson 12. There's just a couple of things at the bottom here that are starred that I wanted to address. First things first, I mentioned this yesterday, but when we are dividing polynomials, we want to make sure that we account for missing exponents. I did an example in Lesson 12 where we had two missing exponents, so we accounted for those with zeros. Second thing is all of the examples we did in Lesson 12, we ended up with the correct constant term at the end. That will not always happen. Okay, there will very often be problems where you do the problem correctly using the reverse box method, but at the end you end up with the wrong constant term. And if you end up with the wrong constant term, that doesn't mean that you did it wrong. That just means that there's a remainder at the end. You might remember learning about division in elementary school, and you had problems that involved remainders. If there's stuff left over, that stuff that's left over is called the remainder. In fact, whatever the difference is between the constant term that you get and the constant term that you wanted, that you should have gotten, is what the remainder is. And the way we're going to write the remainder is as it says here. So we're going to write the remainder as an extra term and a fraction. We're going to write it as a fractional extra term in which the remainder is the numerator and the original denominator is the denominator. And I will explain what I mean by that when I do the examples. So let's take a look at those examples. So the first one we're going to do is the one at the top here. We have n cubed plus 7n squared plus 14n plus 3 divided by n plus 2. First things first, I'll notice that there's no missing exponents here, so we don't have to worry about that. So let's go ahead and set up the box method. So if you forgot from yesterday, the way we set it up is we put the denominator to the left of the box here. So because the denominator is a binomial, I know there has to be two rows. And then I take the first term of the numerator, which in this case is n cubed, and I put that in the top left box. And now I'm going to figure out what goes up on top of the box. So, first things first, n times what? N times what is n cubed? N times what is n cubed? So that's going to be n times n squared. All right, and once I figure out what goes on top of the column, I can finish the column. So n times n squared is n cubed. 2 times n squared is 2n squared. Okay, now I'm going to go to my diagonal. And what I need to do is, what's my next term? My next term here is 7n squared. So the question is, what do I need to add to 2 to get to 7n squared? So I need to add 5n squared. 2 plus 5 5n squared is equal to 7n squared. So now I'm going to do the second column. So same question. N times what is equal to 5n squared? N times what is equal to 5n squared? So it's going to be n times 5n, right? N times 5n is 5n squared. If I finish out the column, 2 times 5n is equal to 10n. All right. I didn't get a constant term here, so I know I'm going to need at least one more column. If I look at the next term is 14n. So when I go to my diagonal, what do I need to add to 10n to get to 14n? So the answer is I need to add 4n. 10n plus 4n is equal to 14n. All right, I'm going to do this same song and dance one more time. So n times what is equal to 4n? N times what is equal to 4n? And the answer is going to be n times 4, right? N times 4 is equal to 4n, n times 4. If I finish out the column, 2 times 4 is equal to 8. Now I got a constant term, so now I know I'm done. The problem is I got a constant term of 8. I got a constant term of 8, but I need a constant term of 3. So I got a constant term of 8, but I need a constant term of 3. So that means there's going to be a remainder. So to figure out the remainder, I'm going to look at what I got. I got 8, but I needed a constant term of 3. So to go from 8 to 3, that means I need to go down by 5, right? If I start at 8 and I go down by 5, that means I end up at 3. So going down by 5 means the remainder is 5. Or excuse me, the remainder is negative 5 in this case. Yes, you can have negative remainders. So to go from 8 to 3, I need to go down by 5. Thus, the remainder is negative 5. So to write out my answer, I'm going to start off up here. So my answer is going to be n squared plus 5n plus 4. And instead of writing remainder negative 5 like I did when I was in elementary school, instead of writing that, I'm going to go back to my lesson notes and write the remainder a different way. So we're going to write the remainder as a fractional extra term, in which the remainder number is in the numerator and the original denominator is in the denominator. So I'm going to write it as an extra term. That's a fraction. And I'm going to put the remainder in the numerator, so plus negative 5 in the numerator, and the original denominator in the denominator, so n plus 2. So my answer is n squared plus 5n plus 4 plus negative 5 over n plus 2. And actually, if you really wanted to get technical, I don't even need to write plus negative 5. Plus negative 5 is the same as subtraction. So I could write the answer as n squared plus 5n plus 4 minus 5 over n plus 2. That right here is the final answer to number 1, to the first one. Okay. Let's go ahead and set up the second one. So I'm going to put 2p minus 7, and then I'm going to put 2p squared in the top left. There's no missing exponents again this time, so I don't need to worry about that. So let's get started here. So 2p times what is 2p squared? So the answer is going to be 2p times p. So 2p times p is 2p squared. Now I can finish out the column. So this one's going to be negative 7 times p. So negative 7p. Okay. If I look at my next term here is positive 7p. So when I go to my diagonal, the question is to go from negative 7 to positive 7p, what do I need to add to negative 7 to get to positive 7p? And the answer is I need to add 14p, right? Because negative 7 plus 14p is equal to 7p. Let's do the next column. So 2p times what is equal to 14p? So the answer is going to be 2p times 7. 2p times 7 is equal to 14p. Negative 7 times 7 is equal to negative 49. That is a constant term, so now I know I'm done. And if I double check my constant terms, notice I got a constant term of negative 49, but the actual constant term was negative 39, which means there's a remainder. So to figure out the remainder, once again, to go from negative 49 to negative 39, to go from negative 49 to negative 39, I need to go up by 10, right? Because negative 49 plus 10 is equal to negative 39. So my remainder in this case is positive 10 this time. So when I write out my answer is going to be p plus 7, and then I'm going to add an extra fractional term where the remainder is the numerator and the original denominator, 2p minus 7, is the denominator. So p plus 7 plus 10 over 2p minus 7. Okay, so that's it for number 2. Number 3, I have x squared minus 74 divided by x minus 8. Notice in the numerator, I have a missing exponent. I'm missing an x term. So I have to rewrite that as x squared plus 0x minus 74 divided by x minus 8. So I have to account for that one missing exponent before I go ahead and I set up the box method. So I know that I need to put x minus 8 to the left here. And I know I need to put the first term of the numerator in the top left. So let's do this problem now. So x times what is equal to x squared? So it's going to be x times x. X times x is equal to x squared. So negative 8 times x is equal to negative 8x. Okay. So when I look at my diagonal here, and I look at my next term is 0x. So to go from negative 8 to 0, what do I need to add to negative 8 in order to get to 0? I need to add positive 8, right? Negative 8 plus 8x is equal to 0x. So that's what needs to go there. Now let's do the second column. X times what is equal to 8x. So it's going to be x times 8. X times 8 is equal to 8x. And then if I finish out the column, I have negative 8 times positive 8. So that's going to be a negative 64. That is a constant term, so I know I'm done at that point. So the question is there a remainder? Well, I ended up with a constant term of negative 64, but the actual constant term was negative 74. So yes, there is a remainder. To go from negative 64 to negative 74, I need to go up or down. Well, negative 64 to negative 74 is down. So we know the remainder is going to be negative. And in this case, it's going to be down by 10. Right? Negative 64 minus 10 is equal to negative 74. So the remainder in this case is negative 10. So my final answer is going to be x plus 8. And then once again, I'm going to write it as an extra fractional term. So it's going to be minus 10. Why minus? Because the remainder was negative. So minus 10 goes in the numerator. And the original denominator, which is x minus 8, goes in the denominator. So my final answer is this right here. X plus 8 minus 10 over x minus 8. Again, we're doing the same thing I did in the previous lesson. The only difference is that the examples in this lesson actually have remainders. Sometimes you'll end up with a remainder, sometimes you won't. So it all comes down to what you get at the end in your constant term. If you get the actual constant term at the end, that means there's no remainder. In the case of all three of these examples, I did not get the right constant term at the end, which means there was a remainder. And that is it for this lesson.